let's take a look at enzymic reactions. Enzymes behave as catalysts in the biochemical reactions. So in this case, enzymes are in fact certain form of proteins, and they basically act as catalysts for biochemical reactions in living organisms. And one of the things to bear in mind is that enzyme depends on its active enzymic site for molecules to sit on it. So this is actually an example where actually a reactant molecule sits on the enzymic site, and then from there itself, the molecules may actually break apart to form two new compounds. And in biochemical terms, the reactant molecule is typically called substrate. While the enzyme will have active sites that they can use to interact with the substrate. And we also need to bear in mind that the enzyme do have a limited number of active sites that they can use to interact with substrate. Let's now take a look at this reaction rate versus the concentration of reactant graph. In this case, we need to bear in mind that the enzyme concentration remains constant. So as the substrate concentration increases initially, you'll find that the reaction rate will increase. The reason is because there's still plenty of available enzymic sites that can interact with the substrate. So as you increase the amount of concentration of reactant, the reaction rate will increase proportionally. However, as the enzymic sites becomes saturated, then you start to see that the rate, although will still increase, is no longer proportional to the concentration of the substrate. And subsequently, it will hit a plateau. The reason why it reaches a maximum and constant reaction rate is because this is when all the enzymic sites are already occupied. It means that when you continue to increase the concentration of the substrate, there is no more enzymic sites available for the substrate to actually interact with. Hence, the reaction rate will remain unchanged. Therefore, in conclusion, when the enzyme concentration is constant in the initial part, we can model that whereby the reaction rate is equal to K con e to the power of 0, S to the power of 1, because it's first order with respect to the substrate, but zero order with respect to the enzyme. However, when it actually reaches this line here, you will find that you will instead be first order with respect to enzyme, because now you have plenty of substrate, but it is the concentration of enzyme that's limiting the rate of reaction. While in this case, no matter how you increase the concentration of the substrate, it does not affect the reaction rate. So this graph also further lends the argument to say that when you increase your enzyme concentration, the reaction rate increases. But obviously, there's one assumption to this. The assumption must be that the substrate must be in large excess.